Hi everyone, today we are going to use some more math strategies to help us solve addition problems. So this says let's solve 15 plus 28. So if I look at this and I start at 15, how many times do we have to jump to get 15 plus 28? So I would have to jump 28 times to get my answer. So let's do it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So I would have to jump 28 times to get my answer of 43. Well, there has to be an easier way to do this. So if we can break our jumps into 10s, or like yesterday we talked about even breaking them up into 20s, we wouldn't have to jump so many times. So let's look at this. If I did 10 plus 10 plus 8, that would equal my 28 jumps. So right here I started at 15, I jumped 10 to get to 25, and then I jumped 10 more to get to 35, and then I added 8, which would be 43, which we've kind of been practicing already. So that's how I can break my jumps up instead of just counting on when we have higher numbers. Okay, let's look at this. So let's start at 28 and then count up. So, okay, so I'm going to start at 28 and now I want to add 15. So if I wanted to make this easier, I could add a 10, which would mean I would just go straight down to 38. And then I would just have to add 5. 1, 2, 3, 4, 5, and I get 43. So let's look at this. This number line up top is where we started with 15, and then we added 28. Okay, so I had to add 10, and then 10 more, and then 8. Whereas on the bottom, I started at my larger number, which is 28, and then I added 15, which then I only had to jump 1 10 and then 5. So it's definitely easier if you always start with the larger number. So if you're going to use a number line to help you solve problems, always start with the larger number so then you don't have to do so many jumps. Because adding 15 is a lot easier than adding 28. Okay? All right. Let's look at this. Okay, jumping by 10, starting at 28. We're going to skip that. Okay. This is another way that you can break the problem down to solve the problem. So if number lines, if you don't feel comfortable with number lines, you can break it up this way, or we can always stack it like a hamburger, and I'll show you both ways. So right here, we started with our equation 15 plus 28. Well, then I took 15 and I broke it down into 10 plus 5, okay? And then I took 28 and I broke that down into 20 plus 8. Okay, so I took my equation and then I broke it down into 10 plus 5 and 20 plus 8. From there, I'm going to add my 10s and my 10 and my 20 together. So 10 plus 20 equals 30. And then I'm adding 5 plus 8, which equals 13. And then I can easily add those together to get my answer of 43. So that's another way that we can break it down. And this kind of tells you how I did it. 10 plus 20 is 30, and then 5 plus 8 is 13, and then 30 plus 13 is 43. If you don't like breaking the numbers down and you're not a fan of number lines, or you just want to try another strategy, you can always break it down or stack it like a hamburger, I mean. So 15 plus 28. Okay, I like to break it, separate my ones from my tens. So this is my 1 spot up here, and this is my 10 spot up here. I know 5 plus 8 is 13, so I put down my 3. I can't just write 13 down here because that 1 belongs in my 10 spot. So I'm going to carry my 10 over and then add my 10s together. So I have 2, 3, 4. 43. That's how I can stack it like a hamburger. So 3 different strategies. You can break up the number, stack it like a hamburger, or use a number line. But if you use a number line, always start with the largest number so that you don't have to jump so many times. All right. Now I would like you to get out your math notebook. And we started a vocabulary page in the very last section of your math notebook. So if you need a second, pause the video, get your math notebook out, turn to the vocabulary section. Your first word should have been variable. And now we are going to add the associative property, which is the sum of the addition problem, which means the sum of the addition problem will not change regardless of how the numbers are grouped. So this is going to help us when we are adding multiple numbers together, which we are going to practice right after this. So go ahead and write this nice and neat in your vocabulary section in your math notebook. If you need more time, pause the video. If you are ready, then we are going to move on. We are going to use the associative property. So when we have problems like this, 23 plus 13 plus 8 plus 12 plus 7, we really want to group those numbers together to make it easier. So if I wanted to solve this, I could add 23 plus 13, and I could use any strategy I'd like to solve this problem, but I'm going to stack it like a hamburger. So 3 plus 3 is 6, 2 plus 1 is 3. So that means that these two numbers equals 36. Now I'm going to add these two numbers together. Actually, I am going to add 7 plus 8 together because I know 7 plus 8 is 15. So these two numbers equal 15. Okay, and then I'm going to add 15 to 12. So then over here I can stack it like a hamburger. I can break my numbers down, or I can use a number line to do this. 15 plus 12. So 5 plus 2 is 7. 1 plus 1 is 2. Okay, now I've gotten my equation down to just 2 numbers. So then I would just add those 2 numbers together. I would do 36 plus 27. Okay, 6 plus 7 is 13. So I'd put my 3 down, and I would carry my 10 over to my 10 spot. 1 plus 3 is 4, 5, 6. 63 is my answer for that top part. So that is a lot easier to do than trying to add all of these numbers all at once. So what the associative property says is I can group those numbers any way I want to, and I will still come up with the same answer. If I wanted to group, let's see, let me change my color. If I wanted to group 23 and 12, and then add 13 plus 15, I could do that and still get 63. It doesn't matter which numbers I put together, I will still get the same answer. Okay, So if you need more time with that problem, you can pause the video. I'm going to erase and then we will do the second problem together. And it might help too if you get a piece of paper and you do this with me, because it might be kind of confusing if you just watch me. But if you do it with me, you might understand it a little bit better if you're confused. Okay, so let's look at this one. 12 plus 8 plus 13 plus 7 plus 23. Okay, I'm going to add my 8 and my 7 together again because I know 8 plus 7 equals 15. Okay. Then I'm going to add 15 plus 12. So I'm going to add 15 plus 12. You can do this on a number line. You can break them up however you need to do. I like stacking it like a hamburger. So I have my 1 spot, my 10 spot. 5 plus 2 is 7. 1 plus 1 is 2. So now I know 15 plus 12 is 27. Okay, now I'm going to add 13 and 23 together. So I have 13 plus 23. 3 plus 3 is 6. 1 plus 2 is 3. So now I'm down to my two numbers, 36 and 27. So I can add those two numbers together to get my answer for this problem. 27 plus 36 equals, I could separate my 10s from my 1s if I need to. 1 spot, 10 spot. 7 plus 6 is 13. I carry my 10 over to the 10 spot. I have 3 plus 3 equals 6. 63. Okay, so the reason why I got the same answer is because these are the same equations, they're just in a different order. So it proves that you can add any numbers that you'd like in any order and come up with the same answer. Okay, so let me show you real quick how to add 27 plus 63 on a number line. So if you really like number lines, let's do it on a number line. So I'm always going to start with my largest number, which in this case is 36. Okay. Then I want to add 27. Okay, so this shows that I have 2 10s and 7 1s. So I can add either 20 right away or I can add 2 10s. I'm going to add 20 right away because I think multiples of 10 are pretty easy to add. So I'm going to add plus 20. So I know 36 plus 20 is 56. Then I would add 7. Which would equal 63. If you're not sure what 56 plus 7 is, you could always maybe add 5 first, or add 4. So if I added 4, that would get me to 60 because I know 56 plus 4 is 60. Then I would only need to add 3 more because 4 plus 3 equals 7. So I would add 3 more. And then I would get the same answer of 63. Okay? So remember, when you see long equations like this, group them together to make it easier on you. Okay, let's look at our worksheets for today. So this is page 19 in your student book, in your Bridges student book. It's called Counting On and Measuring. So for number 1, you are going to count on by tens to fill in the blanks. So 27, 37, blank, 57, blank, blank. You're going to fill that in, counting by tens. And then for B, you start at 122, and you are going to count by tens to fill in those blanks. Number 2 says, solve the problems below. Show all of your work using numbers, words, or labeled sketches. Use your math journal if you need extra room. So letter A says, Patrick measured a book that was 27 centimeters long. Katie measured another book that was 40 centimeters long. If Patrick and Katie lined up the books, how long are the books together? So for letter A, you are going to want to add 27 plus 40. Okay, 27 plus 40. You can use a number line to do that if you need to. You would just make sure that you start at 40. And then you can either hop by tens or hop the whole 20. You could do plus 10. And then that would bring you to 50. And then plus another 10. That would bring you to 60. And then you would add another 7. Okay? And then you would get an answer of 67. So letter A is done for you. Okay, letter B says Abby measured 6 markers. They were 25 centimeters long. If she lined them each in a row, end to end, how long would the row be? So this one's a little bit tricky because we have 6 markers and each of them were 25 centimeters long each. So that means I have to add 25 6 times. So 25 plus 25 plus 25 plus 25. So that's 1, 2, 3, 4. Okay, I need 2 more 25s. And plus 25. So this is an equation that you definitely want to group your numbers together to get the answer. So make sure you're grouping those numbers together to get the answer. Letter C, Colin measured a poster. The first side of the poster was 88 units long. The second side was 25 units long. So how much longer was the first side than the second side? So that means we're comparing, so you're going to want to subtract for letter C. Letter C is a subtraction. Number 3, Kendra has 13 marbles in her collection. Kyle has some marbles in his collection. Together, Kendra and Kyle have 30 marbles. Which of the following equations represents this situation? So remember, the letters in these equations are called variables. Okay? So you need to find an equation that would represent this problem. Okay? For page 20, this is called monkeying around. Number 1 says, during the week, a monkey named Charlie ate 6 bananas, 12 pears, 14 strawberries, and 18 apples. How many pieces of fruit did Charlie eat that week? So you have to add for this one 6 plus 12 plus 14 plus 18. So definitely group up some numbers there to solve your answer. Okay? Number 2, the monkeys made a path around some bushes. How long is the path? So on this one, you're going to want to add 13 plus 7 plus 12 plus 8. So group your numbers again. Okay, that is very important. Number 3, count on by tens from each number below. So you're just going to fill in these boxes, counting on by with the numbers that are counting on by tens. Oops. And then number 4, you're going to solve each problem below. Explain your thinking in numbers, words, or labeled sketches. So again, you're going to want to group those numbers together. Okay, and remember that it doesn't matter which numbers you put together, you will still find the same answer. Okay, you are going to turn both of these pages in using Kami. If you have any questions, please let me know.